Welcome to the Data Future channel. This is Shekhar and I am a data scientist. In this lecture, we are going to see the time series forecasting. Whenever we come across the time series, its series means it's a number of observations which are taken at equal interval of time. So here the time column may be the timestamp itself. It may be on hourly basis, minute basis, or it may be on day basis. Okay, it may be on the basis of months or years. Okay, so but in this tutorial we are going to see the time series forecasting using ARIMA model. So let us quickly start uh, the practical using the time series data actually. So first what we have to do, so we have to import all the required libraries. So mostly what happens, we required the pandas libraries, we required the NumPy, we require the matplotlib for the visualizations, and here we want some more models which can be used for the statistical modeling. Okay, these things we required for the advanced visualization so that we can easily create the visualizations. Okay, interactive visualizations we can say. Okay, the next step is we have to load the data. So my data is in CSV file, so already that is already in my folder in the Jupyter notebook. So directly I loaded this data, reading this CSV file by using a pd.read_csv. So here I am going to see my first five the observations or the data or the row wise data. You can see this is nothing but the data frame. Okay, now there are three columns. You can see the year is the time, what we can say is a time column. Okay, so this is the retailed value is the actual values, so that we have to carry out the analysis over this is the segments actually. Now this data is about the boats which we manufacture, boat manufacturing, the sales we can say. Okay, so next thing is we can check the what is the size of the data. So 793 the rows, and basically we have seen the three columns. Okay, so if you check the how many number of BBG segments are there, so you can see these many number of segments are there, and you can list down these segments also. So these are the segments, and their values are given as per this timestamp. Okay, so here we are going to do the analysis for the aluminum fish, which is one of the segment actually. We will carry out the time series forecasting for this particular segment. So next thing is we have to carry out the data pre-processing, that we will filter the data for the aluminum fish, and we'll check here. So now there are 61 rows and 3 columns again here. So you can see these are the dates. Now you can see here that these data is quarterly data. So the first one is the month and second one is the first date. Okay, the first 1 1 4 1 7 1 and 10 1. You can see 2000. For the 2007 you will see there are four quarters. Okay, yes. Now what we will do, we will pre-process the data. We will drop this because we need not require this column. Okay, BBC segment, so we drop this, and we have to convert this column into a date time format. So pd dot to date time is the function we are using to convert this date column into a proper date, what we can say, because initially it is in strings actually. So you can see here, so where it is. Okay. Yes. Now what you have to do, here we are changing the index. So considering this year as the index and the retail value as the only value. So this is the data pre-processing we did here by using removing this column, then converting into a date time this column, and setting this as the index. Okay. Now, next thing is we have to visualize the data. So how to visualize the data? You can see here df.plot, and we provide the figure size. So directly you can see how your data looks like. Yeah. Yes, you can see here the year wise, you can see this data, time series data, and these values are for retailed. So this is the column. Okay. Now, for the time series decomposition, means we have to check the three parameters or the components. One is the trend, seasonality, and the noise. Okay. So, trend means how what is the behavior of this particular curve, whether it is upward trend or downward trend. Seasonality means at particular time you can see there is a um, these patterns are repeating over the period of a certain period of time, so that is called as seasonality. And noise is, this is not working as per because what we are considering, this should be um, abnormality. The noise is nothing but the abnormality in the time series. Okay. Yes. So by using we will plot these three components by using this decomposition. So we have already imported this model, that is the statistical models, and here the TSA dot seasonal decompose, and we are providing here the data frame. This is the data df1, and we are selecting model as the additive, and then we have to plot this. Okay. Now you can see, yes. So you will see this is our data. Now you can see the trend line. Okay. Here you can see the seasonality, how over the period of time these patterns are repeating, and here you can see the residuals basically. Okay. So this is about the time series decomposition. Later on, we have to more focus on the time series forecasting using the ARIMA model. So ARIMA means it's the two models. One is the auto regression, and here is the moving average, and in between there is a I, that is the integrated. Okay. Now, so ARIMA is auto-regressive integrated moving average model. Okay. So this model combines these two models. Okay. By using the three factors or the parameters, that is called as the PDQ. So here you can see the P is the order of autoregressive term, that is the AR term we can say. The Q is the order of moving average, and D is number of times we are carrying out the difference, because whenever we have to carry out the analysis of any time series data, so we have to make this series stationary. Okay, then you will get the good results here. So before doing the analysis, we are making this the time series stationary. Okay. Now, AR part of the ARIMA indicates the variables of interest is regressed on its own lagged. Means what auto regression means? The data points are the next data point is depends upon the previous data points. Okay. So what happens? There is a dependency on the previous data. Okay, so the next data or the next data point is calculated based on the relationship between this previous previous data points. So that is the auto-regression. So they are having the correlation in between. Okay. So MA is the part of moving average. Here it indicates the regression error. Um, this regression error is actually a linear combination of error terms whose values occurred uh, con- uh, at various timestamp which is in past. So basically what is happening, so the regression error we are considering for the moving average actually. Okay, that is the Q value, and D value is it's integrated indicates the data values has been replaced with the difference between these values and the previous values. This is because we have to integrate it by differencing the time series so that we will get the stationary time series here. Okay. Now here we are selecting find the optimal parameter of PDQ. Okay, so for that you can see here. So we have selected these values from 0, 1, 0, 1 um, in the range of 0, 1 and 2. So mostly what happens, we require these values in between 0 and 1 only. Okay, so we have selected here the range 0 to 2. Okay, so PDQ list, we have used the iter tools and dot product of PDQ. So it will create all the combinations of PDQ. Okay, so whenever I run this, you will see these are the combinations. Okay, 001, 0012. Okay, yes. So here you can see this will create um, this will create the combination actually. So initially it will create 0 1, then 1 here, then 0 1 1, 1 0 1, 1 1 0, and 1 1 1. So it will create this 1 2 3 4 5 6 7 8 8 combinations. Okay, so it will create the 8 combinations of this PDQ. And for seasonality, we are considering 001, 12, 00. Again, same kind of combinations we are making here. Okay. Then find how to find the optimal parameters PDQ. So we are checking for this PDQ and the seasonal PDQ so that it will give you the best value. And for that, what we are selecting for seasonal PDQ is here, these values, and the PDQ is the list of these tuples. Okay, so initially we are checking for each and every combination. So initially we are checking for this to all these combinations. Then here you can see here we are building a model first, smtse dot tsa state space dot sarimax, the seasonal ARIMA we can say. So df is the data, the order is the param. So param means whatever is the value here, that param. The seasonal order is the param seasonal, means this one, this value. Means we are checking everything. So data, this PDQ order, this seasonal PDQ. Info stationarity is false. Here we are considering, and info's invertibility is equal to false. Okay, because already we are considering this stationarity here. Then after that we will result equal to we will feed this model to this particular data, and finally we'll get this thing. So we'll get the ARIMA, this PDQ value, seasonal PDQ value, and AIC result. So how to choose the optimal parameters? The optimal parameter is chosen based on the lowest AIC value. Okay. So when you run this, you will get so many values here. So first combination, you will get this much of AIC. You can see these AIC values. Here 650 is the lowest one. So you can select this one also. We'll check. Yes, 622 is the lowest. Yes, 620 is also lowest one. So means it is, yes, 60649 is the lowest one. Okay. Now 634, 638, 641, 615 is also there. So 606. Okay, 60679, but 49 is already lesser than that. Yes. So I think we got this value, that is 60 here itself. 606, where it is. This is 79, but one more value was there, 60649 actually. Yes, here it may be. Yes, here it is. So we will select this as our optimal model, and we'll create one more model here. So this we are selecting the best model, which is the lowest AIC value. Okay. Now we will build the model again. The ARIMA model, we will see SMTSA state space dot sarimax. Here you have to provide the order. So order is this one and this one. Stationarity false. The result we have to model dot fit, and result summary will check in the table 1. Okay, now you can see here the table 1. Okay, now here it is very difficult to find this diagnosis of the model, so that we will plot the results dot plot underscore diagnostic. This function is there. So whenever we check these things here, so you will see standard residuals are um, around this. In the QQ plot, these points are following this red line, and this KD plot is also following this one. You cannot find the maximum one, so you will see this model is working fine. So what we'll do, so we will validate this forecast actually. Validate this forecast using the model predictions actually. So how there is the difference between actual and the predicted values. So what I'll do, so I'll create a predicted is equal to results dot get predictions. So I'll start predicting the values from this the 2017. I'll plot till the final one. Okay, so this is the your confidence interval we are selecting, and here we are having observed values. The prediction dot predicted means plot this one step ahead forecast is equal to 0.7 figure size. The x dot fill between these values for the color we are selecting, the alpha level we are selecting, and here we are having the x and y one, and we will plot this. Okay, now you can see here, so we are having the confidence interval also. This confidence interval also we are plotting along with this. So you can see here this the predicted one So one step ahead forecast is predicted values are also following the actual value here. Okay. So till 2022 results we are getting. So means the model is working fine. So you can see here, this is the Y truth we are considering, and here is the predicted value. These are the actual values and these are the predicted values. So if you calculate the mean squared error, so mean squared error value is this one, and root mean squared value is this one. Means this is the lowest value we are getting for this particular model with these PDQ values. Okay. So here what we are doing, we have to predict the future. Okay, now this model is okay. Now I want the data, because it's a quarterly analysis. So I want the data for next 3 years actually. 3 years means till 2025. Okay. So yes, I will use this results.get forecast and this thing. So here you will get these are the forecast for next 12 steps. Okay, so you can see this one. Now if you want to visualize this again, you can use this thing, um, this forecast for your further analysis, and you can check. Okay. Yes, now you can see here, this is your actual data, and these are the predicted values. Means what will be the your sales of your boat on this first quarter. This is second quarter, third quarters. No, this is the second quarter, third quarter, and fourth quarter. The same thing for next. So according to that, you can plan your inventories and all these things, so that you will get the idea how much require the material you have to order, and the manage your sale, okay, accordingly. So this is the one approach of predicting one by using ARIMA, and here we have used the optimized value to select the values of these PDQ and the seasonal PDQ values. Okay, so this is one, and here we have selected the smallest value of AIC to get the good results. Now our model is working fine, and we can predict for the future also. So this is all about the implementation of ARIMA model to forecast the boat sales. Okay. This is all about time sales forecasting by using a ARIMA model. Thank you.